Good morning, sir. This is Yutuba Farzana from the Department of Triple E. Today, my topic of ISM Introduction to Synchronous Machine is Principles and Operations of Rotor Frequency and Rotor Speed. The presentation explains the fundamental principles governing electric machines and their operations. It covers concepts like rotor EMF, frequency, rotor current, and power factor at standard time. Understanding these fundamentals is essential for analyzing the behavior of electrical machines during startups and normal operations. This is the whole introduction of principles of operations. Basic structure of electrical machines. Electrical machines typically consist of stator and rotor designs to work together. The stator generates at a rotating magnetic field while the rotor interact with their field to produce torque. The behavior of these components at standstill is crucial for understanding initial machine conditions. Principles of electromagnetic induction. Electromagnetic induction occurs when a conductor experiences a magnetic flux. In electrical machines, the relative motion between magnetic flux and conductor includes EMF in the rotor. This EMF is fundamental to operations of both rotors, machines, and generators, especially at a standstill position. Rotor EMF and frequency at standstill. The rotor EMF and frequency at standstill is when the rotor is at the stator position. The rotor includes due to rotor EMF includes due to stator's rotating magnetic field. The EMF magnitude depends on the stator flux and the rotor's position relative to stator field. At standstill, the rotor EMF is proportional to the supply frequency and the machine's construction. This is the whole explanation of rotor EMF and frequency at standstill. Rotor current at standstill. The rotor current at standstill is mainly determined by the EMF divided by the rotor's resistance and impedance. Since the rotor is stator, the rotor circuit behaves like a transformer primary winding and a short circuit. High rotor current at startup are typically necessary for developing the initial torque. The role of frequency in rotor EMF. The frequency of rotor EMF is already linked to stator supply frequency and slip in an induction machine. At standstill, slip is 100% means rotor EMF frequency equals to stator frequency. As the rotor speeds up, the slip decreases, alternating the rotor EMF and current accordingly. Power factor at standstill. The power factor at standstill reflects the phase difference between voltage and current in the rotor circuit. It is typically low at startup due to high rotor current and reactive effects. Improving factors involves reducing reactive power and controlling rotor current during startup. This is the power factor at standstill. Impacts of machine starting. Understanding rotor EMF, current and power factor helps in designing effective starting methods. High rotor current at standstill necessitate protective measures to prevent overheat. Proper control of initial conditions ensures smooth startup and prolongs machine life. Summary of key principles. This is the whole summary of key principles, which includes electromagnetic induction underpins the generation of rotor EMF and current at standstill. Rotor EMF at standstill is influenced by supply frequency and machine construction. Power factor at startup is generally low but can improve with appropriate techniques. Whole conclusion of this topic is mastery of these principles aids in conclusion and practical applications. Mastery of this principle aids in turbine shooting, and optimizing electrical machines' performance. Engineers can improve starting products by magnetizing rotor EMFs, currents, and power factors. Continuous research and development enhances the efficiency and reliability of electrical machines. Thank you. This is the whole explanation about the topic. Thank you.